So today we are going to be talking about these special triangles and also talking about how to use them in order to find the missing side lengths here. So there are two special triangles. And now I know it looks like there's four, but there's actually only two. These two are the two special triangles in degrees, and then these are the same two, just converted to radians. If you want to learn more about converting from degrees to radians or vice versa, I do have a video on that. But basically, these are the same triangles just repeated again with radians. Now, the thing about these two triangles are that these triangle ratios are always going to be the same no matter what. And so if we have a triangle that has 30, 60, and 90 as the numbers of degrees, or a triangle with 45, 45, and 90, all triangles like that have the same ratios, right? They're all similar. And so, therefore, if we know these special triangles, we can extrapolate that knowledge to figure out the missing side lengths for other ones. So I'm going to give you an example to show you what I mean by that. So let's start with this first one down here. This one is a 30, 60, 90 triangle, and we know that this side length that's adjacent to 60 is 5. Now, on our original one, the length that's adjacent to 60 is the square root of 3. And so in order to find the missing side lengths, essentially what we need to do is we need to divide everything by the square root of 3. So let's do that. If we divide 5 by the square root of 3 to get this other side length here, we know that if we multiply top and bottom by root 3 over root 3, we get 5 root 3 over 3. And so therefore this side length here is 5 root 3 over 3. Okay, and I just want to reiterate, how did we come up with 5 root 3 over 3? Well, we know that this side length here is 5. On our original one, this side length here is root 3. And so how do we get from root 3 to 1, right? How do we get from root 3 to 1? We divide by root 3. So therefore, we must do the same thing to the similar triangle. We have to divide 5 by root 3 to get 5 over root 3. And then in order to get from 5 over root 3 to 5 root 3 over 3, we just multiply the numerator and denominator by root 3 in order to get this more simplified version of the same thing. Okay, so I'll delete that and we'll just keep the final answer here. Then the next question is, well, how do we get from this side length here to the hypotenuse? Well, over here in the original special triangle, to get from 1 to 2, we have to multiply by 2. So that means we must do the same thing to the similar triangle. We have to take 5 root 3 over 3 and multiply it by 2, which gives us 10 root 3 over 3. And so there's our answer. Okay, let's move on to B. So B is the 45, 45, 90 triangle. And I can see that one of the side lengths is 7 root 2. Now, how do we find the other side length? Well, here it looks like both side lengths are the same, right? Both of these side lengths are the same thing. They're both 1. And so therefore, on a similar triangle, if one of these side lengths is 7 root 2, the other also has to be 7 root 2. These both must be the same thing. Then, how do we find the hypotenuse? Well, how do we find the hypotenuse on this one? Well, how would we get from 1 to square root of 2? We multiply by square root of 2. And so therefore, what we can do is take 7 root 2 and multiply it by root 2. So we get 7 root 2 times root 2, which is just equal to 7 times 2, which is equal to 14. So therefore, this side length here is 14. Okay, let's do part C. Part C is another 30, 60, 90 triangle. However, it's in radians. So instead of 60 degrees, it says pi over 3. And instead of 30 degrees, it says pi over 6. Okay. So going back to this one here, what do we have? We have that the hypotenuse is 2. And over here, the hypotenuse is 6. So how can we find the other side lengths? Well, over here we have 2 as our hypotenuse, and then this one here is 1, and so it's half as big. That means that this length here would also have to be half as big, as the hypotenuse. So this length would be 3, right? Because that's half of 6, just as 1 is half of 2 in our original. Then how about this other side length here? What do we have to do in order to get this side length here? Well, we have to take the purple side length, the 1, and multiply that by root 3. So in this case, we have 3 for this side, and so we have to multiply that by root 3 to get this side length. So that would be 3 root 3, like that. All right, and then what about our very last one here? There we go. We can see it a bit better. This one has 9 root 3 as the hypotenuse side. And it has pi over 4 for the angle. So this is another 45, 45, 90. But again, it is written in radians in this case, but it's essentially the same thing. Okay, so let's go to this one here. What do we have to do to root 2 in order to get 1? Well, we have to divide it by root 2. So that means in order to get these other side lengths, we have to take 9 root 3 and divide that by root 2. Now, that isn't really in simplified form. We need to make sure that we don't have any radicals in our denominator here. So I'm going to multiply top and bottom by root 2. And if I do that, I get 9 root 6 over 2. And so therefore the answer is 9 root 6 over 2 for these side lengths. And if we could simplify this, like if we could do 9 divided by 2 and actually get a whole number, then we would, but we cannot. So we can just leave it as 9 root 6 divided by 2. As always, if you have any questions, feel free to leave them in the comment section, and we'll see you for the next one.